Hello everyone, Notorious here, and today I'm continuing my Red Sport series where we look at logic gates, and eventually this will lead to me building a computer in Minecraft. We're way far away from that right now, so if we just get ourselves turned around, last time we covered every single logic gate in Minecraft, all 16 of them. There's a lot, and we don't need most of them. Because in actual computing, the only gates we're going to need are the NAND, NOR, and NOT gates, which are, I've rebuilt them over here, except that's makes into an AND gate. But yeah, so we have NAND, NOR, well, this is OR, and NOT. The reason this one here is OR instead of NOR, because in real world, it's NOR. It's due to how silicon and, I don't, something about silicon and how it interacts with electricity. Basically, real world, we use NOR gates. Minecraft, OR gates are easier. So we're going to use OR gates. And the only real difference between the two is if I grab this, plop that there, boom, NOR gate. NAND gate, boom, AND gate. And the reason that is actually really good is because we can make any one of these just out of these three. All we need. So actually, I'm going to go through this one right here. I believe this is the Zor gate. Also, if you can't tell, we are in 1.17, and I decided to glue all my signs. So that's a thing. But yeah, we're going to go through the Zor gate, which I've pulled up on the side. And let's see, we're going to actually do it right here. So we're going to do it together so you guys can kind of get an idea of how we should be thinking. So we have our two input lines. And normally what I like to do, when like actually building out the gate, would normally be, I'm gonna actually, all right, now I have some other blocks that look similar, not exactly the same. The reason I'm doing that is I'm gonna come here, and then we're gonna do this and this. We're gonna do the same thing on this side, so terracotta, and concrete. There we go. So this is going to pass through on these ones. And then we're going to actually put torches right here as a NOT gate. So now we have all four of these. So we have, actually what I'm going to do as well. This is another thing that's kind of important. Computers tend to be very time sensitive. So if you can make sure that all of your paths actually have the same timing, that is super useful. And I am slapping blocks in the wrong places. So now these two update on the same tick. And now what we're going to do is we're going to build out two gates. The reason for we're doing two is if we look at the output, there's two places where it is 1, so true. And those two places are actually where we want to check for. And we look at our inputs, and if it's a 0, we take the NOT of it. So we're going to do NOT. Let's actually label these. Sign. Do sign. I'm going to label this one Y, and this one X. So we're going to take NOT X and Y, and then we're also going to take, so NOT X and Y, or not Y and X. I hope I'm not confusing you. Because basically what we're going to do here is I'm just going to pass through, let me see, I need to, and it's fine. Space is one of those things that we're not worried about right now. Yeah, so we'll go and over, and then fortunately we are in Minecraft, so we actually have three-dimensional space to work with. Computers normally don't. So I'm going to pass all these around like so. All right, now what we're going to do is if we come over here and we take a look at this guy, this is our NAND gate. We're just going to build this over there. So all we're going to do, except to make this an AND gate, we can do that. So we're going to AND these two inputs together, which means a block and a block, torch. We get white concrete, and then realize that this is not matching. There we go. Now we're going to put that into a line of dust. Goes into a block. We're going to put a torch on that. And there we go. Our first AND gate. And then we're just going to build the same thing over here. So let me do that real fast. All right, now that we have our two AND gates, we're just going to take the OR and output it. So actually, all we have to do is that. I'm just going to grab a lamp and plop that there. So now if we come over here, 0, 0 gives us a 0. That is good. Next one is going to be a 0, 1, and that gave us 1. Next one is going to be 1, 0. That also gives us 1. Finally, 1, 1. That gives us 0. You can see it's working. And all this is we just moved our cables around, made two AND gates, combined them with an OR gate. And this principle is actually just how you make any logic gate in general. It's the easiest one. I'm pretty sure there's like sites out there that you can put in combinations using all 16 of them, and it'll give you a formula that looks something of the form. We'll say like this is going to be a terrible example, but we'll say that's AND. Then like we have a couple other things that are ANDed, and then there's some more over here. And then very end, these are just all ordered up together. So technically these are all, yeah, hopefully that made sense. Mathematically, it's basically you have a bunch of parentheses, and is considered multiplication, quote unquote. I'm going to get a lot of flack for this in the comments, but we're computer scientists are lazy. We just say multiplication is AND, addition is OR. You do multiplication first, so you do all of your ANDs first, and then you just OR them together. It is literally that simple. I'm making it sound a lot more complicated than it is. But now you should all have a general idea of how to combine logic circuits together. If you want me to, I might make a more complicated one. If there's demand for that in the comments, definitely let me know if you want a more complicated one for me to walk through. Because I can do that. Otherwise, I think next time what I'm going to do is tackle this monstrosity over there. Yeah. We're going from this to that. So don't be scared. It's not that bad. We're going to see that because this is how, or this is a real world version of something. And then we're just going to completely ignore it for the rest of existence because it is disgusting and I never want to see it again after that. But thank you all for watching, and I will catch you all in the next one.